Okay, so we have on this worksheet, you have reflected that beginning figure on both graphs over the x-axis. That would be figure number 1, the figure that has the 1 in it. And then you flipped that initial figure over the y-axis. That would be then the figures that are labeled 2. And then I had you draw the line y equals x on both of those as a dashed line. Remember, we get that line y equals x by whatever x is y, the y coordinate is. So if x is 1, y is 1. So we'd plot the point 1, 1, 2, 2, 3, 3. Or we could plot -2, -2, -3, -3. So that's how we got that dashed line. So now we're going to flip our beginning figure, bless you, over that line. And thankfully, all of our figures are on, all of our points are at whole numbers or integer values. So this is at the point 1, 2, and this one's at 1, 5, and so on. So to reflect it over this line, you're just going to draw the diagonal from here to there. And that will be the perpendicular to that. So let me show you that again. So the diagonal that would go from that point through that line is going to be perpendicular, and so you'll end at that point across, and that's where we will label. So the protractors really are only being used to help you draw a straight line. So you want to identify a point right there. There's going to be one point that I'm going to graph. That's my point M prime. And then if you need to still draw, go ahead and draw this segment that goes from here to our dotted dash line. Notice you're going to have to cut those squares in half. That's how you're going to get the perpendicular segment. And then you'll go the opposite direction. So here I cut from end to the dash line. I went through 2 squares, correct? So I'm going to go the opposite direction, 2 squares as well, and cut those squares diagonally and put a new point there. That is my N prime. And then P is going to cross the other direction. And again, we are going to draw the segment that will cut that square in half. So that's the perpendicular to that dashed line, and then that means I only did one, went through 1 square, so I will only go 1 square on the other side. And that is my point P prime. And so then connecting those 3, whoa. Which I don't like that. So you don't necessarily need to draw the segments. If you can just identify, okay, from this point E, I need to go and cross that line, and it will have to go through the diagonal so that I get to this point. If you don't want to draw that segment, you don't have to. You can just go ahead and put the point where it will be. So go ahead and do that for this second figure, the figure on the right. Let's reflect that figure over the line y equals x. So I'm not going to show the line. I'm just going to show you where the point would be, and then I will connect my points. Okay, so I'm going to start with point E, and I'm going to reflect it over the line y equals x. So point E is half of that square to get to that dashed line. So I'm going to go the other half of that square and put a point, and that's my E prime. Point F, to get to the dashed line diagonally, bless you, I go through 1 square. And so that means I need to diagonally go through the other 1 square on the opposite side and then put my F prime point. G, diagonally to get to the dashed line, I go through 1, 2 squares, so I need to go diagonally through 2 squares on the other side of that dashed line. 1, 2, and there's my point G prime. H, I go through diagonally 1 square to get to the dashed line, so I'm going to go through 1 square diagonally to get to the other point or part H prime. And then I will connect those 4 to give me the reflection of that figure over the line y equals x. Okay, so then the last type of reflection we're going to look at is we're going to reflect it over the line y equals negative x, or the opposite of x. So if x is 1, what's the opposite of 1? Negative 1. So that would give us the point, this point right here. 1, negative 1 would be there. If x is 2, y would be the opposite of that, or negative 2. If x is 3, y would be the opposite of that, negative 3. 0, there's no opposite, so it would stay at 0. If x was a negative 1, the opposite of that would be positive 1, so that would give us this point. Negative 2 would give us positive 2, and so on. So we would have the line that goes through those. So I'd like for you to draw that dashed line. Both directions, please. Okay, in order to reflect our original figure over our original image over that new line y equals a negative x, you follow the same things that we did for the line y equals x. So here's our initial point M, and I'm going to go to this dashed line, but I'm going to cut through the square diagonally to get there. So point M goes through 1.5 squares to get to our dashed line here. So I'm going to have to go through 1.5 squares on the other side diagonally to get to the point M prime. So 1.5 this way, 1.5 that way, and there's my point M prime. Make sure you're doing this. N cuts through 1, 2, 3 squares diagonally, so I'm going to go the other direction 3 squares diagonally, 1, 2, 3, and I'm going to put point N prime there. And then point P, I'm going to my dashed line y equals negative x, diagonal through the squares, so 1, 2, 3, 4 squares diagonally to get to that dashed line. So I'm going to go 4 squares diagonally the other direction. 1, 2, 3, 4. And I'm going to connect those points, and that will be the image of triangle NMP reflected over the line y equals negative opposite of x. Oops. Okay, so now I want you to do the same thing for the figure on the right. We are going to cross, actually I need to draw my line y equals negative x on this side, and remember that goes through the point 1, negative 1, 2, negative 2, 3, negative 3, and so on. And then it goes through negative 1, 1, negative 2, 2, and so on the other side. Oops. So here's my figure EFGH, and right here I'm going diagonally through the squares to get that to that dashed line. That's 2.5 squares that I'm going through, so I have to go the other direction. 2.5. There's a half. 1, 2. Point F goes through 1, 2, 3, 4 diagonally to get to the dashed line. So I'm going to go for the opposite direction diagonally. 1, 2, 3, 4. There's my point F prime. G diagonally. 1, 2, 3. So other direction. 1, 2, 3. And then H is just 1. So I go 1 there. And I am ready to draw my figure E prime, F prime, G prime, H prime. And that's the figure reflected across the line y equals negative x. Rather than having to graph every time we want to reflect over either the x-axis, the y-axis, the line y equals x, or the line y equals negative x, to find our other points, we can just use these rules right here, and I want you to put those in your notes, that table. Rules for reflections on a coordinate plane. It tells you that when we have the point xy and we reflect it over the x-axis, it will become the coordinates will be x negative y. When we reflect it over the y-axis, xy becomes negative xy, and so forth. So get the table that's on page 67 in your textbook, in your notes, rules for reflections on a coordinate plane. So after you get that table in your notes, then I need you to put these two problems in your notes, and you're going to have them ready to go by tomorrow. Using that table, you want to reflect points S, T, U, and V over the x-axis. So what would S prime be, T prime be, U prime be, and V prime be in terms of ordered pairs or the location? And then part B, you're going to reflect points A, B, and C over the line y equals negative x using the chart that you just put in your notes. What would A prime's coordinates be then? What would B prime's coordinates? And what would be C prime's coordinates? So have those ready to go for tomorrow. And then we're going to discuss, if we're given two figures, one's the reflection of the other, how do we come up with the line that they were reflected over? So that will be our discussion tomorrow.